Hey everyone, this is a video answer key for the 6A through 6C practice quiz. So let's go ahead and get started here. The first question is, what is the opposite of the number that is graphed on the number line? So if we look at this number line, we can see that the number is 5, and the opposite of any integer is the opposite sign. So if we're looking at positive 5, its opposite is negative 5. It's the same distance away from 0 on a number line in the opposite direction. So since this is 5 units away from 0 and to the right, then 5 units away from 0 to the left would be negative 5. So negative 5 is the opposite for positive 5. And looking at question 2, it says, what is the opposite of 11? So same idea. The opposite of 11, since 11 is positive, its opposite would be negative 11. The opposite sign. Now be careful, because when we get down here to absolute value, one of the things that kids often do is they mistake absolute value for opposite. And absolute value is not the same as opposite. Absolute value just means how many units away from 0 is the number. It's not positive or negative in that sense, except the answer is always positive. So anytime you're taking the absolute value of a number, it's 5. Anytime you're taking the absolute value of a number, it's the number in its positive form. So it's always positive. So for the absolute value of 5 is going to be then a positive 5. Absolute value is always positive. Absolute value is a distance, and distance is always positive. We don't travel in negative directions. We always travel in a positive direction. So when we get to question 4 and we want the absolute value of negative 15, that's a 15. That's positive 15 because it's 15 units away from 0 on the number line. Just like 5 was 5 units away from 0 on the number line. Again, absolute value, it's always positive. Maybe you could think of those two absolute value symbols. If we took them and we could move them around, we could make them into a plus sign. Absolute value is always positive. That's a big mistake kids make, is they confuse that with opposites, and it's not the opposite. Number 5 asks us to use symbols to make this statement true. So I'm going to draw a number line here, and just to remind you that we kind of put 0 in the center of our number line, and then over here would be our positive numbers, and over here would be our negative numbers. And anything to the left of another number is less than that number. So 0 is less than 1, and negative 1 is less than 0. So the further you go to the left, the smaller your numbers are. Therefore, negative 7 is less than negative 1, because negative 1 would be here, and negative 7 would be down here somewhere. So negative 7 is less than negative 1, and so we would choose our less than symbol there. All right, let's go on to question 6 here. So question 6, same idea. Use those symbols, the inequality symbols, to make this a true statement. Again, if we drew our number line, we've got our 0 in the middle. 11 would be over here, negative 11 would be over here. So negative 11, because it's further to the left, is less than positive 11. And so positive 11 is greater than negative 11. Negative 11 is smaller than positive 11, so we want the greater than symbol here. Same thing with question 11. We want to make this a true statement by using one of the inequality symbols. And so again, I have my number line. 0 would fall in the middle. Negative 2 is going to be to the left of 0. So negative 2 is smaller than 0. So we want the less than symbol there. All right, looking at this one is number 8. We need to tell what quadrant the point is. So the point is right here. The graphed point is right here. And remember that we label these quadrants so that they make a C. This would be 1, and oftentimes you'll see that as a Roman numeral. This would be 2. This would be 3. They go counterclockwise. And then this one would be 4. And those are your Roman numerals. So again, just think about a C. If you're a Chicago Cubs fan or a Cincinnati fan, think about a C, all right? Okay, so our graphed point right here actually falls then into quadrant 2. So we want quadrant 2 there. All right, same thing for number 9. Which quadrant does the point fall in? Again, make our C 1, 2, 3, 4. We make a C 1, 2, 3, 4. So this is in quadrant 4. And so we would choose quadrant 4. Number 10, which ordered pair names the graphed point? And so we have our point. We know that we're going to do the x-axis first. We go right to left first and then up and down. Okay? So it always goes alphabetical. It's x, then y first. And if you remember, if you make an x and flatten it, that shows you your x-axis. If you make your y and flatten it, that shows you your y-axis. So the y-axis is our up and down, our vertical, and our x-axis is our right to left, our horizontal. Okay. All right, so we have to go over 7 units from 0. We start at 0, over 7 units, and then up 3 units. So this is 7, 3. So again, we started at 0, went over to 7, and then up 1, 2, 3, 7, 3. All right, same thing for number 11. Which ordered pair names the graphed point? Oops, flipped too many pages there. All right, so we're going to start at the origin. Remember, this is called the origin. Start at 0, 0. We're going to go back or in the negative direction to -5, and then again down, so that's negative, to -1, 2, 3. So -5, -3 is what we're looking for here. So -5, -3. This is back 5, down 3. Okay. Then number 12 asks us, the ordered pair that names point W is -6, 3. If you reflect W across the x-axis, what new ordered pair would you get? So we want to reflect across the x-axis. This is our x-axis here. And we want to reflect this point across that axis. So what we're saying is, if I would fold right along this line, where would that point fall on the other side of that line? It's a mirror image. And so what we're going to do, because we're reflecting across this line right here, we're going to go to the same line that W falls on, and as many spaces as it is, as many, I should say, lines as it is above the x-axis, we're going to do that many lines below the x-axis. So this is 1, 2, 3. So we're going to go down 1, 2, 3 instead of up. So right along -6, right along the same coordinate here on the vertical, we're going to go down the same amount of spaces that we went up. So this is the reflection. If I folded it on this line, this point, and this point would fall on top of each other. There's symmetry there. They're symmetrical. And so the point we're looking for then is -6, -1, 2, 3. So we want -6, -3. All right, so question 13 then, similar. It says the ordered pair that names the point U is 2, -1. If you reflect U across the y-axis this time. Now instead of x, we're going to do it across the y-axis. What point would we get? So we're going over this axis now. So we see that we're going to stay on this line, but we want to reflect it across here. So if we want to stay on -1 on the x, but then we'll go, since we're 2 spaces away from y here, we want to be 2 spaces away from y there. So again, if we would fold this on this y-axis, these two would fall on top of each other. They're symmetrical, like butterfly wings. They're symmetrical. They're going to fall on top of each other. Another way to say that is they form a mirror image. And so we will find that new point is back 2, so -2, down 1. -2, down 1. So that's this one. Alrighty. And then we're going to go on to number 14. And this one says to find the distance between 310 and 910. Well, the 10s stay the same, so that's not going to tell us anything, but the 3 and the 9 change. So we can see there's 1, 2, 3, 4, 5. And Mrs. Schaefer pointed out to you in our notes earlier, we don't count the spaces, we're counting the lines. From this line to this line is 1, and then 2, and then 3, and then 4, and then 5, and then 6. Sorry, I said 5 earlier, didn't I? 6. The difference between 3 and 9 is 6. So this is 6 units apart. Okay. All right, and then this one, same idea. We're counting the lines, but I'm going to do some math here. From here to here is 5 units, and from here to here is 10 units, right? Because to get to -10, this is 10 units. And to get to positive 5, this is 5 units, so that's a total of 15. Remember, distance is never negative, so it's not going to be negative 15, it'll be a positive 15. We could also count that. One line to the next line is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So you can see 15 there. All right, guys, that's the practice quiz. If you have any questions on this quiz, make sure that you contact us before you take your summative quiz. Hope you're all doing well.